How are we doing today? Hopefully y'all are doing well. So we will be continuing our notes on bonding today. All right, so let's take a look at bonding. All right, so for this, you do need to make sure you've got your notes, something to write with, and then you should also have a periodic table. All right, so let's go ahead and get started. So we are going to be focused specifically on metallic bonding. All right, and if y'all remember, when we talked about this with the introduction to bonding, we talked about how metals or metallic bonds are bonds that form between metals. Now, what does that mean? What does a metallic bond look like? Well, for metallic bonds, we're not actually going to be sharing or giving away electrons. Instead, we're going to put all of our electrons into just this giant sea, this giant place where all the electrons are free to move wherever they want to move. Now, this is what gives metals a lot of their properties. This is what gives metals the properties that they have. All right. So, for metals, they're going to have this low ionization energy. Now, if you remember, ionization energy is going to be the energy required to remove the outermost electron, right? So for metals, we know that because they are metals, they have low ionization energy. And so kind of this idea of how the sea of electron forms is that all those electrons, because there's a low ionization energy, those electrons are actually free to move around all of the other atoms, which results in this sea that they can all have access to those electrons through. Now, what this does is this actually gives metallic bonds the properties that we think of with metals. So they're going to be great conductors of heat and electricity. They're going to reflect light. So they're also going to be malleable and ductile. Malleable is essentially what it means is to be able to bend without breaking. Or like if you hit it with a hammer, does it tear or does it like actually just form a little dent? That would be malleable. Or ductile. Ductile means to be able to be stretched into a wire. Well, we know that metals are actually able to do these things because of the properties that they have with their electrons, because of that sea of electrons. All right. It's also the reason that metals have very high melting and boiling points. And an exception to that, yes, is mercury. We know that mercury at room temperature is actually going to be a liquid, right? But we know with metals, if we're talking about their melting and boiling point, what we've found is that in general, it's going to increase their melting point as we move from left to right. So if I'm comparing something like sodium to aluminum, they're on the same row. Aluminum's got a much higher melting point than sodium does. And we know that as we move down, the melting point is going to decrease as well. So if we go from lithium down to, for example, potassium, we would continue to see that melting point decrease. So for metals, the important thing that you know, the important thing to help you prepare for your tests and quizzes and anything like that, is that metals have a sea of electrons, and that sea of electrons is what gives them the properties of like good conductor, high melting point, ability to reflect light. Is it ductile or malleable? Those are all properties because of the sea of electrons. All right, so that is metallic. So very short, very sweet, right? Three and a half minutes, and we're done with metallic bonds. Okay, so the very last thing here is organic nomenclature. Now, this is a type of nomenclature where we've got specific combinations of elements, and they result in a certain set of names that we have to give and certain formulas that we use. Okay. Now, an organic compound is going to be a compound that's going to involve taking a carbon and linking it to something like a hydrogen, an oxygen, or a nitrogen. We're going to focus specifically on what we call the alkanes. Now, there's technically a couple of other types of organic compounds. We have alkynes, alkanes, and alkenes. But we're going to focus on the alkanes. Now, for your alkanes, they do have a formula. The formula is your carbon and hydrogen. So you're going to have carbon, and you're going to have a number of carbon. And then to figure out how many hydrogen you're going to have, you're going to take twice the number of carbon plus 2. Okay? So this is our formula for that. So it is the number of carbon And then you have your hydrogen, and your hydrogen number equals twice the number of carbon plus 2. Okay, where N is again the number of carbon that we have. Looking at our organic compounds, you are going to need to know these 10 organic compounds. So we've got methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. So you are going to need to know the formula and the name for all 10 of those organic compounds. So you're like, okay, well, how do I know? How do I remember those organic compounds and the order that they go in and their formula on top of everything else? How do I remember? Well, I focus on the first 4. So to help me remember those first 4, I say mice. So mice eat peanut butter. Okay, mice eat peanut butter. Pretty simple, but the purpose of that is to help you remember those first 4. Because if you can remember the first 4, the rest of them are based off of those prefixes that you used for your covalent compounds. So penta, hexa, hepta, octa, nona, deca, those are all going to be based off of those. So if you remember the first 4, everything else is just based off of your prefixes. Okay, so how do I know what to do? Okay, so let's say I was given methane. Okay, well, if I'm given methane, I know that methane is related to the mice in my mice eat peanut butter, right? So methane is the first one. So that tells me I'm going to have 1 carbon. Okay, and you're like, okay, well, it's a carbon bonded to a hydrogen, right? Well, how many hydrogen? Well, if you remember, the formula is carbon, number of carbon. Hydrogen is twice the number of carbon plus 2. So I have how many carbon? I have 1 carbon. So twice the number of 1 is 2. So 2 hydrogen plus 2 more. So 2 plus 2 is 4. So that tells me that methane is going to be CH4. All right. So what if I was given butane? Well, again, let's think about this. Mice eat peanut butter. Okay, so that's the 4th one, right? So if I'm looking for butane, if I need to know the formula, C4, right? Because it's the 4th one. Mice eat peanut butter. So the 4th one. And I need to know how many hydrogen. So my hydrogen is twice the number of carbon plus 2. So twice the number of 4 is 8, plus 2 more is 10. Okay, so I know that I can solve for my formula given that. Now, let's say if they give me my formula here, and they're asking for the name. So I have C6H14. Well, first off, 6 is not 4 or less. Now, why did I say 4 or less? Because 4 or less is going to be mice eat peanut butter, right? So it's not those 4. So then that tells me that I'm going to think about my prefixes. So what is the prefix for 6? Well, my prefix for 6 is hexa, right? Okay, so now I know my prefix. Well, all of these are my alkanes, right? So these are my organic compounds. How do they all end? Well, they all end in ane. So this is hexane. So if I had C10, H22, and they asked me what is the name of this organic compound, what you would tell me would be, okay, well, it's not in the first 4, right? So mice eat peanut butter, so it's not in those first 4. So then I'm going to have to use my prefixes. So I look at my carbon. What's the prefix for 10? Deca. We add the ending ane, ane, to that. So this would be decane. All right. All right. Well, that is it for our organic nomenclature. Again, don't forget you are going to need to know those names and formulas. And then don't forget for your metallic bonds, you just need to know essentially the C of electron is what gives the properties of metals to metals. All right. As always, let us know if y'all have any questions, but otherwise, y'all have a great rest of the day. Bye, y'all.